Hello friends, welcome back. Welcome to the Concepts of CISSP series. We are covering Domain 3 Security Architecture and Engineering. This is episode number 5. We have already covered few architecture and engineering principles like economy of mechanism and fail-safe default. In this video, we'll be talking about a term which is called complete mediation. This is also a very key fundamental architectural and design principle, and there is a different kind of vulnerability which is called TOCTOU vulnerability. I will be explaining that vulnerability and how it relates to the complete mediation. So what is complete mediation? So complete mediation is about having absolute control over each and every transaction a computing system is performing, right? So going back to our original discussion, how we originally defined a computing environment. We defined a computing environment by the term trusted system, right? A trusted system is a computing system which is having a baseline security which is agreed, right? Or which is established. Now that baseline security is established using a concept which is called trusted computing base. The trusted computing base is a concept which says that it's a collection of minimum hardware, software and firmware which acts together to ensure the baseline security of a trusted system, right? So we discussed trusted system and we discussed trusted computing base. And when it comes to the transactions happening in the trusted system or using trusted computing base to perform different functional features of the computer, right? We discussed a term which is called reference monitor. So what is reference monitor? Reference monitor is a piece of hardware, or it's a concept basically which is used to ensure the access control mechanism of the trusted system. So who will access what at what level is managed by reference monitor, right? Now in discussion of trusted system, trusted computing base, reference monitor, we use this term transaction. So transaction is basically any activity initiated by a subject to an object, right? Now we will focus on this transaction part within the trusted system in understanding complete mediation, right? So when it comes to complete mediation, it means that each and every transaction is authenticated, right? So when it comes to authentication, what we think in our mind, we think of user authentication, right? Or a program authentication. Here we are talking about any interaction between any subject, whether it's a physical user or a user defined in an operating system or a system user or a user defined in an application. So any user, any subject, when it starts a transaction to any object, whether accessing a file, reading a file, writing a file, or executing some program, right? So there is a subject, it starts a transaction to an object. So each and every transaction thread, if it is authenticated for its identity and authorization, right? So we have to remember these three terms. So first, we are focusing on transaction. So each and every transaction is what? Authenticated for what? Identity and authorization. If this is happening, it means that we are following the principle of complete mediation, or in other words, we can say that the principle of complete mediation is upholded by the trusted system, right? Again, in a formal way, we can say that the principle of complete mediation says that each and every transaction in a computing system or a trusted system is authenticated for its identity and authorization. This is complete mediation. Now the transaction itself is having a property which, if it is upholded, the system is better secured, and this is called what? This is called atomic transaction or atomicity in some sense. Atomic transaction says that in any transaction, when subjects start a transaction towards an object, then starting from the time of commit, the time of commit is the time when a subject starts the communication, or starts the transaction to the produced output, right? So every action will produce some kind of output. So from the start of time of check or time of initial interaction to the system, starting a transaction towards the generation of the output, the transaction is not tampered, or transaction is not basically it's not interrupted. Then if this condition is met, then we can say that the system, trusted system, or the computer is following the principle of atomic transaction, or the atomic transaction property is embedded in that trusted system. So atomic transaction means that the transaction cannot be interrupted, changed, modified, or whatever between the input and the produced output. This is the simplest way to understand atomic transaction. Now we will be discussing two vulnerable situation, and the second vulnerable situation is called TOCTOU vulnerability, which is time of commit to time of use vulnerability, right? Now the first vulnerability which I'll be discussing in the context of complete mediation is something which is called authorization caching. Then take an example of a subject using using any computing system to access a file, right? So when the subject starts the transaction, that point is called time of commit or time of check, right? So time of check from the perspective of the server or perspective of the computing system. Now at that time, at the time of check, what happens that his credentials are authenticated, right? So the user starts the transaction and the transaction is authenticated for its identity and authorization, which is the principle of complete mediation, and he gets an access, and with the access comes some authorization level, and this authorization is given for a time period, right? Now if this authorization is cached somewhere in the system, cached somewhere within the server, it doesn't matter where it is cached, but it is cached, right? That you will be getting, let's say, 20 minutes of access. Now what happens, like if the owner of the object or the owner of the file decides not to give you access after, let's say, 15 minutes, and he revokes the access, and you are still continuing to have access because your access authorization is cached and your authorization decision is based on the cached information, then for the rest 5 minutes you will be having access, but the owner of the file, the owner of the system, do not wanted you to have the access. This is a vulnerable situation, and this 5 minutes gap is a vulnerable window which can be exploited by an attacker, or the user, if he is not an attacker, he can make unexpected changes which is not expected by the owner of the system, right? So this is a vulnerability which we have to be mindful of. So when we are discussing any situation, or when we are having a system which is working on cached authorization information, then even though we have the atomic transaction in place, this can be exploited, right? So the questions can come that if atomic transaction can be exploited or not, and if one of the option is reflecting the idea of authorization being cached, so that is likely to be the right answer. What is TOCTOU vulnerability? This is a very common discussion around the software developers, right? Because they are more interested in this vulnerability. I am not a software developer, so unfortunately I can't give you a live TOCTOU vulnerability demonstration, but I will give you an analogy which will help you in understanding this concept and knowing what you should know for CISSP exams, right? So I would like you to go and see a movie which is called Snowden, and in a Snowden movie you will see that this character who is an engineer in a facility, he actually copies some file and he put in a Rubik cube, and he gets that information out of the building, right? There is a very beautiful sequence. I think thumbnail of my videos have depicting those flows. So there, if you will see that part of the movie, you will realize that it's an hacking attempt. It's not hacking from outside, but it is hacking from the internal network. Now, what Snowden does is he uses a pen drive or a thumb drive, you can say, and copies confidential files in the drive, and he hides that drive in a Rubik cube and use social engineering later on with the security guards to bypass that Rubik cubes from the security scan, right? And then he gets the information out. Now the point where he logs into the system, that's called time of check, right? Now time of check was the time when he logged into a system and his identity and authorization was verified. But if you notice that in the movie the computer was already on, so he actually overrided the existing time of check of another user and plugged into the pen drive or flash drive to copy the file, right? We'll just take that moment as a time of check when he actually logged into the system or his friend logged into the system. And afterwards, what happens when he copied the file, he was still into the authorization window, right? So that was the time of use. So time of check was when he started logging into the system, or he logged into the system and then he copied the file. That is the time of use. Now that time of use was exploited, right? And this exploitation, after this exploitation, he did social engineering and he used other techniques, right? So this is one way to visualize what is time of check and time of use. In a very simple term, to understand this vulnerability in a different perspective, you can think of a subject accessing a file, right? So when a subject tries to access a file, then what happens? Time of check starts. He gets a time window, right? In the time window, he writes the file, and while he is writing the file, he is aware of an underlying vulnerable vulnerable path which exists in the system which can be exploited, right? Or a redirection vulnerability, more like log4j, right? So what he does is he writes some piece of code which redirects the transaction to a secret file and read the content and send it back, right? So what will happen in this situation, that although you have a complete mediation, like you mediate the transaction is authenticated, authorized, you get an authorization window. But in that authorization window, since attacker is aware of an underlying vulnerability, he uses that authorization window to generate an attack, right? So this type of vulnerability is called TOCTOU vulnerability, where you are using a time window which is between the time of check and time of use in favor of your attack, right? So I hope this makes sense with my drawing. The attack for using this TOCTOU vulnerability is only possible when you have an underlying vulnerability which can be exploited, right? Generally in computing systems, this time window between time of check and time of use is very small. And if you want to use that time window, you have to spam the system with too many calls, too many transactions. It's difficult, but it's not impossible, right? So this can be used to go to certain locations which are forbidden, which is not cleared for your authorization, and you can get the data. That's basically TOCTOU vulnerability. How this TOCTOU vulnerability can be stopped? The TOCTOU vulnerability can be stopped only when you have atomic transaction is in place, right? So what is the quality of atomic transaction, or what is the property of atomic transaction which prevents TOCTOU attack? The principle of atomic transaction says that as I have already explained before, that the time when you provide the input and the time when the output is generated, in between these two times, the transactions cannot be altered or the transaction cannot be changed. If this principle is upheld by the system, in addition with the principle of complete mediation, then TOCTOU vulnerability is difficult to be exploited. I hope this makes sense and is useful. Let's meet you in another video with further discussion in this domain, security, architecture and engineering, and best of luck for your CISSP exams.